Hi, everybody. Welcome to Math 60. This is the video lecture for section 1.1. As I do these videos, occasionally I might need to pause and check my notes. And if I need to do that, sometimes it takes me a little bit to get the mouse over to where I need to pause it. So if it seems like I just stopped talking for a second, give yourself a little bit of time. Probably I'm just working over to get it to pause the video. All right, section 1.1 is all about variables and expressions. So variables and expressions, these are ways to organize mathematical ideas. So a variable is used to represent an unknown quantity. It's often represented by a letter. The most common letter is X. X represents an unknown variable. Often Y is the companion, or Z. I write my Z's with a little dash here so you can tell that they're not the number 2. Sometimes we use a letter that links to the word. So for example, when the variable is time, we often use T for the letter. If you've ever seen the formula distance equals rate, which is another word for speed, distance equals rate times time. And if we represent that in letters, we often write D equals R times T. By the way, when I write math, my multiplication symbol is going to be a dot. Sometimes to represent multiplication, we also just use a parentheses, or even a parentheses and a dot. Parentheses can mean something else also, and it's context dependent, whether as a parentheses means multiplication or if it means a function, which we'll be talking about later. So a variable is used to represent an unknown quantity. Variables often show up in mathematical expressions. I know there are higher tech ways to do your math for YouTube videos. I still prefer paper. My handwriting gets even worse when it's digital handwriting. And also the paper is just kind of what I'm used to. So variables are used in mathematical expressions. A mathematical expression is like sentence, and that is it is a combination of variables, usually represented by letters, and numbers, using arithmetic operations like plus, minus, times, division, etc. So you could think of variables as words and expressions as sentences, if you want to think about it that way. Now, with mathematical expressions, what we often do is we evaluate. So to evaluate a mathematical expression, is to replace the variables with specific numbers, and calculate the result. And for a lot of the rest of this section, we're just going to be doing that in various different ways. So let's jump right in. Examples, evaluating expressions. So let's evaluate 13x where x equals 5. So we take 13x equals 13 times 5. We're doing the evaluate expression thing here, so we're going to work our way down. 13 times 5 is 65, and we're done. We've replaced the variable with the specific number, and we calculated the result. Let's evaluate a slightly more complicated expression. How about 4x minus 12, and we're going to take all of that and multiply it by 2. For x equals -3. So we take 4x minus 12, multiply everything by 2, and we're going to replace the x with the -3, so it becomes 4 times -3 minus 12, all multiplied by 2. This would be a good time for a refresher on our PEMDAS order of operations. First, we do anything in parentheses. Then we do anything with an exponent. Then anything involving multiplication. Then anything involving division. Then anything involving addition. And finally, subtraction. Technically, you can switch addition and subtraction, but it's a little easier to read that as a word when we say PEMDAS. So using that, we see, okay, I've got this parentheses here, so we want to make sure we do anything in the parentheses first. So we've got a 4 times a -3, which is a -12. And then we have this -12 times 2. We're still working inside the parentheses. minus 12 is negative 24 times 2. And now we've got a multiplication. So now we multiply negative 24 times negative 2, and we get negative 48, and we're done. Oops. We replaced the x with the negative 3, and we calculated the result. Let's keep going. Evaluate the absolute value of 7x minus 4 for x equals negative 10. So one really important piece of evaluating or working with mathematical expressions is to be able to take something that looks like a formula and understand what it means in words. So the vertical bars is read as the absolute value of 7x minus 4. Absolute value of 7x minus 4. And what that means is calculate 7x minus 4 and make it positive no matter what. So if 7x minus 4, once we evaluate it, is a negative number, we simply make it positive. If it's a positive number, then we leave it positive. So we have 7x minus 4 and we're going to put in x equals minus 10. So it's 7 times negative 10 minus 4. 7 times negative 10 is negative 70 minus 4. Negative 70 minus 4 is negative 74. Everything is still inside the absolute values. And now I take this number and I make it positive, and we're done. Okay, one more example from our basic formula only evaluation. Let's evaluate the square root of 3x plus 8 minus 2 for x equals, I'm going to pause while I come up with a good example. All right, let's change that to 3x plus 9. For x equals 24. So again, we need to recognize that this mathematical symbol is read as square root 3x plus 9 is read as the square root of 3x plus 9. And the operation is find the number that squares to what is inside the square root symbol. So we have the square root of 3x plus 9, and then subtract 2, and we're going to plug in 24. So that's the square root of 3 times 24 plus 9, and then we subtract 2. The square root operates kind of like a parentheses. So we always do what's inside the square root before we want to add or subtract from it. So we have 3 times 24, that's 72, plus 9, minus 2. Again, since the square root acts like a parentheses, we want to do what's inside first. So we have the square root of 81 minus 2. The square root of 81 is 9, and then we subtract 2, and so we get 7, and we're done. So evaluating expressions with more than one variable. So as an example, let's evaluate, let's see, 3 times 2x plus 4 minus 7x plus 1. For x equals 5. The process works the same way. We replace every x with a 5. So it'd be 3 times 2 times 5 plus 4 minus 7 times 5 plus 1. And then we work through our mathematical operations. We have a parentheses, so let's do that first. 2 times 5 is 10 plus 4. And then minus 7 times 5 is 35 plus 1. Do what's inside the parentheses. So we have 3 times 14. I'll go ahead and combine the negative 35 and the plus 1. That's going to be minus 34. 3 times 14 is 42. Let me subtract 34. And I believe that's 8. And we're done. By the way, I've done arithmetic enough that I'm pretty confident just doing addition and multiplication, division, subtraction in my head. There's no requirement for you to do it that way. You are welcome to use a calculator for each and every step. Keep track of your order of operations, though. I would not put this whole thing into a calculator just like that. I would say, as I'm working through this, I need 10 plus 4, so I grab my calculator to show me that's 14. Or I need 3 times 14, and I grab my calculator to show me that's 42, rather than try to do it all in one long chain, keeping track of all the parentheses and order of operations, etc. That's more difficult. But calculators are totally fine. I would encourage you to build some, to work on those times tables, for example, work on your addition, especially more complicated addition and subtraction, but calculators are, you're welcome to use those. All right. So another example of evaluating expression with multiple variables. Let's do 5x plus 6y minus 4. All right, so now we have two different variables for x equals 2 and y equals 1. The process is the same. Replace all your x's with 2 and all your y's with 1. So we have 5x plus 6y minus 4 equals 5 times 2 plus 6 times 1 minus 4. 5 times 2 is 10. 6 times 1 is 6 minus 4. And for space reasons, I'll combine all this at the same time. 10 plus 6 is 16 minus 4 is 12. And we're done. So that's how we evaluate general mathematical expressions with 1 and 2 variables. However, usually in mathematics, we are using these expressions in order to answer questions about things we care about. And outside of the math classroom, we generally don't care about it, just an expression like this living by itself. So mathematical expressions are most commonly used to represent word questions. Now, word questions are a challenge for me to write out because that's a lot of writing, but I can do a couple here and there. So let's see, a farmer wants to build a paddock. That's an enclosure for usually horses, sometimes other animals. Um, that is a 10-meter by 3-meter rectangle. The long sides are wire and cost, let's see, $2 per meter. The short sides are wood and cost $7 per meter. What is the total cost of the paddock or enclosure? So what we're basically doing here is we're going to convert this word question into a mathematical expression that then we can then evaluate to answer the ultimate question: what is the cost of the paddock? And it often helps when possible to draw a picture. So I'm going to draw a picture here. 1, 2, 3. Okay. There's the paddock. This is 3 meters, and this is 10 meters. And the cost here is $2 per meter. And the cost here is, did I get that right? No. The cost here is $7 per meter. And the cost here is $2 per meter. And so we can see that there's going to be 3 plus another 3 meters and 10 plus another 10 meters. So our mathematical expression is going to end up being 10 meters times $2 per meter plus, oops, not 10, 10 and another 10. So it's going to be $20 plus $2 per meter. And then 6 meters times $7 per meter. And so we can evaluate that. That's going to be 40 plus 42, which is $82. Sometimes, so this is an example where we build all the mathematical content from interpreting this sentence or the series of sentences. All right, we built our expression with basically with no help. We drew a picture and we double checked our work and we said 10 doesn't make sense because it's really 2 sets of 10, so it's 20. And then it's $2 per meter and $7 per meter. Sometimes you're given a little bit more information, such as a ball thrown upward from a height of 2 meters has a vertical trajectory. So a way to tell how high the ball is over time, given by the expression height equals minus 16 times time squared. So here I'll use t because it's time, plus 20t plus 2. So here we have a sentence that includes a mathematical expression. And then our question is, how high is the ball after 3 seconds? So let's take a look. One small change, let's say, how high is it after 1 second? So we're still answering a word question, but we're given a little bit of mathematical information as well. So we're looking for the height. The height at any time can be given by the expression minus 16t squared plus 20t plus 2. And we're letting t equal 1, so we just replace each t with the 1. So we have minus 16 times 1 squared plus 20 times 1 plus 2. 1 squared, 1 times 1 is 1, so that's minus 16 times 1 plus 20 plus 2, minus 16 plus 20 plus 2. So we have 4 plus 2, which is 6. And we're given meters as our units, so it's going to be meters high. So if you throw a ball upward from a height of 2 meters and its height can be given by this function, then after 1 second, that ball is 6 meters high. And often when we start with a word question, the expectation is we're going to end with a sentence that incorporates our mathematical understanding. After 1 second, the ball is 6 meters high. That ends our section 1.1 with a basic introduction to variables and expressions, how to evaluate expressions when they're just the formula, and how to convert word questions into mathematical expressions and then evaluate those. Our next video will be for section 1.2. Thanks for watching.